Welcome, everyone. This is Rich Berliner from Connected Real Estate Magazine, and welcome to our webinar today, Building Reliable Connections, What in the Wireless World is CBRS? Some notes before we start the webinar. We will do what we can to answer all questions during the webinar. If not, we will answer them during the Q&A session at the end. If you have a question, please ask it through our GoToWebinar control panel. We are recording and will publish a link to the recording within a few days of this webinar. Today's slides will be emailed to everyone automatically after the webinar is over. And if you'd like more information about this topic, please go to anscorporate.com or connectedremag.com. So I'd like to introduce our agenda now for this webinar. Paul Fatuccia from ANS, Advanced Network Services, will be discussing CBRS overview and ANS introduction. Kurt Jacobs from JMA Wireless will be talking about equipment architecture, SAS, and EPC. Brenda Delaney will discuss network design and deployment. And Ken Hozak from Cradlepoint will discuss use cases and endpoint devices. And then after that, we will take questions from the field. Without further ado, let me introduce Paul Fatuccia from ANS, Advanced Network Services. Paul, the floor is yours.
Good afternoon, all, and thank you, Rich, and our distinguished panel. Also, I'd like to thank everyone taking time out of their day to join us today. First and foremost, we're going to touch on 5 quick topics, a quick introduction to CBRS and OnGo. I'm going to talk a little bit about what CBRS is associated with a private LTE network. Also show you a video associated with the American Dream project, introduce you to the American Dream team, and then also show you another video about who ANS is. So without further ado, Aaron, if you could play the first video, please. Okay, hopefully that sheds some light on an introductory for CBRS. Additionally, I wanted to talk a little bit about what OnGo is. You hear that terminology stated quite often. OnGo is really a certification program that the CBRS Alliance has created to allow equipment manufacturers get standardized on the CBRS platform. There is a slew of third-party certification organizations or labs that actually test the equipment to make sure that that specification to the CBRS platform is intact and that there is interoperability between all components. So having said that, I'm going to move on to the CBRS as a private LTE network. So first and foremost, the spectrum, the 3.5 gigahertz spectrum that facilitates the CBRS network is really first of its kind as a shared spectrum network topology. And what's that mean? As you look through the slide here, you can see that there is a 3-tier program where the owner of the 3.5 gigahertz spectrum today is actually owned by the U.S. Navy. And what the FCC has come up with is a way to better utilize that band. There's going to be actually 3 components that come into play with that spectrum today, or that shared topology. The first is still the incumbent, or the U.S. Navy, still maintaining full control of that space. Second is going to be on the priority access. The priority access is a spectrum that's going to be auctioned off by the FCC come June 25th, 2020. Now that date has been pushed around a couple different times, but as it stands today, it is June 25th, 2020. Also, what's going to happen as part of that auction is that the FCC is going to grant licenses based by county in a regional fashion, and also for a 10-year term. The final piece, or the general authorized access is really where organizations will be allowed to build their own private LTE network. And what's that actually mean? The private LTE network for an enterprise is a LTE-based IP core network. It's going to allow organizations to do a plethora of different types of services on their own in a very secure manner. It's going to allow you to manage various network endpoints, allow for connectivity where wires can't go today, and Ken will talk a little bit about how the cradle point devices actually play into that ecosystem. Next is this, you can actually add on secure or wireless cameras, outdoor remote lighting or indoor remote lighting controlled by this network. You can actually have kiosks in various areas of your facility, whether outdoors or indoors. Additionally, remote signage for video screens to give different information out to your customers, and also finally to connect your smartphone to the network. As we move on, we're going to talk a little bit about the American Dream Entertainment and Retail Facility, which is located in East Rutherford, New Jersey. We have a short little video that we're going to play right now that talks about the American Dream Entertainment and Retail Facility. And hopefully that gave you a good baseline as to what the American Dream experience is going to have for its customers. Next, I want to just really reiterate who the team was that put this project together. First and foremost, we have Kurt Jacobs from JMA, which will talk about the base platform that was utilized in this network topology. Also, Brendan Delaney from ANS, who actually was the architect of pulling the different pieces together to develop this network as an integrator by ANS. And also Ken Hosick from Cradlepoint, which will talk about some of the other devices that were utilized in this network to really give a lot of remote connectivity outdoors associated with the facility. So who is ANS? And ANS has been around since 1991. We have various regional operating facilities. We are an integrator, to say the least, but we also have service offerings in the in-building wireless area, network infrastructure, cell tower, AC and DC power services. And with that, we're going to play another brief video. Thank you very much for your time. At this point, I will hand it off to Kurt Jacobs from JMA, and have a great day.
Thank you, Paul. This is Kurt Jacobs with JMA. That was a great overview of both, and particularly from the customer aspect, the end user, which is really what CBRS and OnGo is all about, and the ANS, the system integration that's able to pull the components together that fortunately now in the industry are ready. There's commercial deployments happening right now, or I should say ongoing right now. And one of the things that we found as we've done early deployments, before I get into the architecture discussion, is really what it means to that enterprise CIO, CTO, Chief Operating Officer. And as the CTO of American Dream indicated, that the CBRS OnGo solution does several things to them, not as a substitute, but as a complementary to Wi-Fi and cellular, and part of his overall enterprise connectivity strategy. And one of the big things that they learned going through this, because they didn't even know, as in, beginning of July, they didn't even know what CBRS was. And what they realized, it's, as I call it, the Homestead Act of the digital age, is where the government is giving individuals and organizations, rather than 160 acres out west to go develop and own and farm, it's 150 megahertz of spectrum that they can use. And that gives them a level of empowerment and ownership for spectrum and solutions that enterprise and building owners just haven't had before. When they came to that realization, that really changed the game. They realized they had what we call a HOV lane of connectivity to connect things. And that resulted in them thinking about how they're going to deploy and operate systems in this complex spectrum environment. Since it's based on 3GPP standards, 4G today, and upgradable, in our case with JMA, via software to 5G without any changing any hardware, they're investing in a solution for the future. And there's devices and technology and that both the integrators know today and can operate, and there's a big selection of devices that have the same security and reliability that you get with commercial cellular services. So that gives them a lot of known interoperability and choice. So that really checks a lot of blocks for the enterprise user. And as we're engaging more customers, they're coming to the same realization. Next slide. So the components for a CBRS OnGo solution really come in several areas. On the bottom right-hand side are all the devices and the use cases, and I'll leave to Ken to go into the details on those. In the middle of it, you have to have a radio access network of some sort. That can range from simple access points that might only handle a few channels of CBRS. Within CBRS, out of the 150 megahertz, there's 10 discrete channels that can be you can get grants to. You can get 10 megahertz or 20 or 30. You can have multiple channels throughout the pace what the spectrum access controller will grant you. The radio access network, if a small solution, a solution like we have from JMA, which is based on our XRAN adapted baseband system, can support all 15 channels. And it goes out to a set of radios that are upgradable via software to 5G and to generate the RF coverage in that 3.5 gigahertz band, and then a selection of antennas to give you the proper coverage. So in many ways, this is no different than systems that are being deployed today for in-building. It's just a different spectrum, and it has an additional connection to the spectrum access controller, which is a cloud service available from 5 manufacturers. So at American Dream, they had around 100 or 600 acres outdoor they needed to cover right away for a traffic management system. That was the initial use case that they brought forward, and he's already talked about in the video the type of savings. What we did is we deployed software into their data center with XRAN, deployed less than a dozen radios around the facility, and just over a dozen antennas to provide coverage for those 600 acres, and providing capacity to support everything, as he said, from 4K video all the way down to simple IoT devices and digital signs. The other component of this is you have to connect to, since it is 3GPP based, is you have to connect to a core network. And the core can be a privately hosted core network that are available from a number of vendors today, or it could be a public or a cloud-hosted core service. That's also a choice enterprise owners will want to consider, not only the capacity of your system, being able to support possibly up to all 15 channels, but are you going to have just private access services in the core networks, or do you want to have public and the potential for roaming capability? Fortunately, with our system, XRAN, we support both. We support multiple core operators, so we can create virtual network slices within the CBRS band. So a customer like American Dream is very excited about that, because they can run several network slices and capacity for their own internal operations, and that is their spectrum that they have no interference, and doesn't take away from the Wi-Fi or the cellular that their guests are using. given their location in northern New Jersey next to MetLife Stadium, you can see the skyline of Manhattan. It's one of the most congested, both in vehicle traffic and spectrum traffic in the country. So having that choice of different core networks was also very appealing to them. So in the future, they can bring in additional services and capacity on that same infrastructure. Even though the initial use case provided some very compelling numbers, in terms of energy savings, space savings, time to deploy, and it's a really testament to the OnGo ecosystem that the 150 or so companies in the CBRS Alliance had several years on to get to the point where this is CBRS that launched in mid-September, and we were able to deploy systems very quickly out of the gate with a large selection of technology available. Next slide. So in summary, the components you have to think about when you deploy a system in the lower right here is what kind of core services you want to use. In this case, we selected GeoVerse as the EPC because they supported both on-premise and they had public services and roaming agreements with carriers. So American Dream wanted to have devices that are not only private, but things that could roam to the outside networks that were off-premise. So that was why they were decided. We worked with Federated Wireless, one of the spectrum access controller companies, and they were important in the planning part because they helped us model which slices of spectrum we were likely to get in that congested area of the country. And that provided the spectrum access system. So those are the back-end services you need to do. And then, of course, they chose JMA, partly because we were already doing the in-building system, and which is also a testament to this technology can be deployed alongside and leverage a lot of the existing infrastructure you might have internally. The initial deployment in American Dream is for the outdoor 600 acres. They'll be adding it indoors in the future for other devices. So it's not unlike many other large-scale venues and city and large-scale enterprises in terms of what the requirements are. And even though they were only doing it for the traffic management system to begin with, to connect all these digital signs, video cameras, video analytics, and so forth, once they realized they had this spectrum and how easily and cost-effectively they could deploy it, that they are now coming to us with a lot of other ideas of things they want to do and use cases. So their marginal cost and benefit, their margin cost will be low, their margin benefit will be very high for deploying this type of system because it gives them that control and empowerment they've been looking for. So with that, I'll turn it over to Brendan to talk about how they pulled all the pieces together.
Thank you very much, Kurt. And what we'll be talking about first here is the Evolved Packet Core, which is the core network here. But as Kurt mentioned on that last slide, Federated Wireless is the spectrum access system and controller that we're utilizing there, and just a little bit more about what that spectrum access system does, which is the SAS. And that is what allocates all the channels that a enterprise or that a PAL eventually will utilize, and it makes sure that all the 150 megahertz, those 15 channels, are utilized to the maximum of their ability without causing any interference. So it's on a daily basis, it pulls all the users in a specific area, and it makes sure that everyone gets a piece of the pie, that it's not interfering and stepping on the toes of another user, but also to make sure that none of that 150 megahertz is not being utilized. So whereas today with the licenses, someone will own a chunk of spectrum, it may not get utilized to the fullest extent. That with the innovative way that the CBRS network is being handled through the SaaS, that gets allocated fully. Those channels are dictated to the customer's evolved packet core, and there's a few different ways to deploy that. The lowest barrier to entry for any enterprise would be a cloud-based solution. It's hosted on a public cloud or co-location, such as Amazon Web Services or what have you. And it's delivered to the customer and to the site via the customer's internet service provider. So it's utilizing your existing connection to the greater internet to get access to your core network. This currently, you can operate data services with that, not necessarily voice services. And also you have a diminished control over latency, bandwidth, and quality of service just because you're sharing that pipe off of what your commercial internet service provider would be, which you may not have the full quality of service control you may want there. And also any of the data that's going through the network does have to go up to that cloud and back down. So very bandwidth intensive uses such as 4K video or something like that will really bog down that network just because everything's got to go up and come back down. You have also the metro-based solution, which you could use a local co-location in your metropolitan area, in your region, in your part of the city. That is delivered by a dark fiber or a dedicated fiber circuit like an MPLS circuit, so that you have a one-to-one pipe back to that metro-based core. With that, you have your improved latency, your bandwidth, more control over the security parameters of the network, and quality of service. It also brings that computing power closer to the edge, which is important for delivering a lot of the next generation services as these networks evolve into 5G networks and additional use cases are layered on top. And then you have your premise-based solution, which is actually what we deployed at the American Dream facility. It's right on campus. They can keep their core data, and it keeps everything on campus, on network. You're only putting out to the larger internet what you need to and what you want to. So you can slice up the network to say this stays here within our core. It allows you to handle a lot more edge computing, a lot more high bandwidth and high quality services, and it gives you the most quality or most control over your quality of service, latency, and bandwidth, and really makes edge computing a thing to drop that latency and allow the most use cases you can deliver here. Next slide, please. And in terms of a network design deployment, it's similar to a traditional in-building DAS, distributed antenna system, or radio network, small cell network design that you would see inside your facilities. The benefit, because of what the SAS does in terms of paying attention to all the channels and allocating the best use to each channel, you don't have to worry about dominance over the outdoor networks. That's part of the design considerations for a distributed antenna system or a small cell system. The SAS mitigates that interference. Design tools, very similar to what we're currently using in an in-building space, and also for the outdoor, whether it's Ivy Wave indoor or an ATOL or what have you outdoor, those tools are improving. Every iteration, every design is feeding back more better information into the system. But at this point, in our mind, CW testing or continuous wave testing, which allows us to mock up where antennas are going to go and make sure that the coverage that you deliver to your endpoints, whether it's your mobile devices as you're walking around or a digital sign that's sitting statically in a parking lot or part of your venue, that they're going to get the incoming network power required to deliver those services. And really, it's a convergence of RF design as well as management, and also IP network design and management to pull this all together, because this is really where convergence is happening. You have your radio access network, you have your customer IP networks, and the services that are being delivered. Also, since you're bringing another network piece into your premise and into your network, cybersecurity planning needs to be accounted for based on what services you're providing and what use cases you're addressing. Next slide, please. All right. And the design models, the what's being deployed at the American Dream resembles a traditional DAS, as Kurt spoke about. That platform has remotes, antennas, fiber, and distributes the antenna via the antennas that have support for the CBRS spectrum. You also have the small cell approach, and that looks a lot more like a Wi-Fi deployment. And really, these are all tools in the toolbox of how to deploy and deliver the use cases that you need for your facility, and you need to pick the best one for your specific situation, same as you have to pick the correct EPC core network for your specific application. The coordination of the activities associated with a CBRS network, from the design, deployment, integration, it really needs to be a company that has a strong project management acumen to bring all the different pieces together, bring the players together, and get it integrated and hand it off to the customer in a holistic way. And because of utilizing these different use cases, the integration happens with a lot of IP and software integration, network coordination, and also managing the different slices for the different quality and the different solutions that are being delivered. And for that, I'll hand it off to Ken Hozak to talk about some of the use cases and devices.
Hey, thanks, Brandon. Appreciate it. If you can go to the next slide. So just a little bit about the solution. I think between Kurt and Brandon, they went through a lot of the infrastructure components. So I wanted to focus on essentially the endpoint itself. And at Cradlepoint, we do essentially 4G-based routers, cloud-based management for fixed locations, mobile locations, and for IoT machines. And what we've done is rather than create a separate SKU for the OnGo CBRS, we've essentially added that capability to our existing modem or existing gigabit LTE SKU. And typically you're going to get a SIM card. A lot of people ask, who's SIM card, but it tends to come from the infrastructure provider. So you put it in there. The solution, because most of these are deployed in these large environments where they're managed, you do need to have kind of enterprise grade management. So a big part of the on-premise solution, as Brandon said, you need kind of that acumen for being able to manage these kinds of services. But the part of the solution is the cloud-based management to handle health monitoring, configuration upgrades, firmware upgrades, but also security analytics, client analytics of what's going on there. If you go to the next slide, I wanted to talk a little bit about the use cases where we're seeing CBRS OnGo is really applicable, or what we call these wide area LANs. So a LAN is a local network, but it's really a situation where you have kind of a large LAN where you do want a private network. And a private network doesn't necessarily mean you can't access the internet. In this case, private LTE means you're operating your own network, kind of like you operate Wi-Fi in your business or even at your house. One of the things that really got our company's attention was we had a business review with one of our large shipping package companies, and they described one of their use cases was a warehouse where they have 500 high definition IP cameras, and they talked about that being a situation where Wi-Fi just really isn't working in that specific scenario. There's a lot of interference in the building with the metal walls. Wi-Fi itself is a contention-based protocol, so if you've ever watched British Parliament, you see people talking at the same time, and there has to be some sort of back off before you figure out who's actually going to talk. And it doesn't work for that application. They could use public LTE, but the problem there is there's way too much content bandwidth that they would have to send up to the public tower. And frankly, I think the mobile operators would prefer not to have someone taxing their towers that much. So private LTE, to be able to set it up in a warehouse with access points throughout the warehouse, have your EPC, that core network locally, because that video is usually going to stay on premise into a DVR, really helps improve the reliability of that network. And that use case is going to be similar to a factory or distribution center as well. Another use case, which is actually very similar or almost identical to what we're doing here with the American Dream Complex, is if you imagine a large amusement park. Right now, a lot of them are trying to use meshed Wi-Fi, but if you think about that amusement park, they contain retail stores, quick serve restaurants. That's what QSR stands for. They have all sorts of vehicles, maintenance vehicles, security vehicles, buses for employees, buses for customers or patrons. And then you have kiosks and digital signage spread out throughout the park, security and surveillance cameras, all sorts of endpoints that need to be connected. And this is where OnGo CBRS makes a lot of sense. You can light up that entire amusement park with your own network, your own private network that you can use for all these applications. And then at the endpoint, the way that this is being used is we essentially, the Cradlepoint solution acts as a gateway to all of the devices that are at that location. So if you have a CBRS router, for example, in a retail store, you're going to use that router to power the point of sale device, the digital signage that's in that retail store. You might have it power security cameras in the store, maybe even customer Wi-Fi locally. So it's taking that CBRS signal and converting it to kind of a local area network. With the vehicle, these days it's amazing, a security vehicle, how much technology is packed into that. You usually have a ruggedized laptop that needs a network connection, often have body-worn cameras and dash cameras. You have sensors in the sirens. If it's a real police vehicle, you might have a sensor in the shotgun rack, because if you pull a shotgun out of a rack, that's a big deal, and they want an IoT alert to go all the way up to the operations center. And so really by having a CBRS router in the vehicle, you can essentially connect all those devices within the vehicle on a local network, and then securely connect that to your enterprise, could be an on-site office or your operations center there. And that's going to be similar to what you'd see at a shipping port or an airport, etc. Smart city, we're seeing all sorts of applications. I talked about the police car. Right now, a lot of the video in the police car is stored in a DVR in the trunk because it's too much bandwidth to transmit 24/7 over LTE. And so as a result, at the end of the shift, the police car goes to the police yard and they offload that video using Wi-Fi. And one of the things that a lot of cities are interested in is putting in LTE access points, not only in the police yard, but also strategically throughout the city, maybe key traffic intersections or key facilities, city-owned properties, so you can offload that video throughout the day rather than at the end of the shift. And you'll see that approach is going to be very common, not just for cities, but we're seeing enterprises for their campus deployments, headquarters deployments, very interested in that. Universities, military bases, oil and gas fields, where you see that. And then finally, on the hospital example, there's the opportunity both within the hospital as well as coming into the hospital from the outside. But in a building like that, and this is going to be similar to an office building or inside of a library or shopping mall, it gives you the opportunity to set up small cells inside the hospital, and maybe it's a neutral host type environment where you can carry the 4 key operators, but also set up multiple private LTE networks within the hospital. You might have one for your doctors and nurses or your other staff. You might have a second private network for your high value assets, like certain medical equipment, and maybe a third private LTE network for the kiosks or that are out in the lobby that provide patient information. But the bottom line is, in a lot of these applications, Wi-Fi just really isn't addressing these large areas very well. One of our potential customers is a shipping port, and they talked about how it works kind of to connect the cranes, but as soon as a cruise ship rolls in with all that Wi-Fi congestion, it really creates a challenging environment. And so private LTE gives these buildings or gives these airports or the amusement parks the ability to set up their own enterprise-grade network using the spectrum that was discussed previously in a way that's very, very reliable. So I think the bottom line is what we've done at American Dream is a perfect example where the initial use case of the digital signage for the traffic management system was enough to justify the ROI for setting up that private LTE network. And as I've described in all of these use cases, usually that initial use, in the case of a shipping port, it might be just connecting the cranes to get a more reliable signal. But once you have that network set up, Now you have the ability to incrementally add other use cases within that environment at a very, very low incremental cost. So that's an overview, and with that, I'll turn it over to Rich for the Q&A session.
Okay, thank you, Ken. Appreciate that. That was really informative. We've got a couple of questions that I'd like to go through. I think we'll start with a question for Kurt. Kurt, someone from the field asked, if a client were to install XRAN, do I need to get the carriers to sign up for this specific install so that roaming can happen between CBRS and cellular?
Thanks. Great question. Today with like what we have at American Dream with Geoverse, and I'm going to introduce some terminology here. You can roam out of the system. So if there's you would put a SIM card into the devices, and let's say you had a Cradlepoint mobile router in, let's say, the American Dream security car, and they go and have a mutual agreement and go respond outside the 600-acre footprint. They can, through the Geoverse system, they already have the agreements with the with carriers to roam and accept as a roamer onto the other network. So you can roam out. That's available today, and you wouldn't have to have a direct connection to the MNOs. If you we're looking to have folks roam in, that's where you had, let's say, a cellular consumer subscriber from one of the carriers want to be able to roam in. Today, those you would have to connect to one of the cores unless there was a special arrangement made for supporting that. That's still in the early days, and we believe that once the PAL auctions are completed mid-next year, and it's anticipated the mobile network operators and the virtual network operators will be using some of those. And there needs to be more smartphones that support Band 48. There's 11 today from 4 different manufacturers, but we all know the turnover rates. It's going to take a year or two until there's enough phones out there probably to justify the roaming in architecture, plus the PALs. Fortunately, a system like XRAN supports is ready to accept those, both PAL connections and roaming in when those are available. So that's something in the business model that will evolve over the next year. There's nothing technology-wise preventing it. It's more of just the industry and catching up to that type of integration.
Just informationally, if anyone else has a question, please ask it. Don't forget to ask it through the portal because we are taking questions that way. So this is back to the ANS team. The question was asked, how do you deal with the fact that each antenna on a CBS system has to be registered and the location noted as part of the registration of the system? How do you deal with that in the design phase of this?
Well, it doesn't have to be registered until the deployment phase of it. So, but you just need to plan for it. That registration happens as a part of dealing with the SAS in terms of the spectrum access system. So you register it with the SAS that you sign up to for your network, or you work with your integrator or managed service provider to select that spectrum access system. And the way it gets done is you need to have a certified professional installer, which anyone who's deploying a CBRS network and is active and engaged in space should either have that on staff or have access to that capability. And that certified professional installer needs to denote any of the locations that are outdoors or above X number of feet in the air or above a certain output power. So that's really the threshold that gets cut there. And you need to have that certified professional installer to complete that registration process. And that's a check on both the integrators as well as on the system to ensure that the information that's being input is accurate and complete. Because if it isn't, then that spectrum access system and the orchestration of spectrum cannot be properly done on a day-to-day basis. All that information needs to be kept up to date and input correctly for the system to work properly. And if it's deemed or looks like it's out of the norms, the spectrum will not be allocated as needed because it would be causing interference with other responsible parties on the network. I think that should.
Yeah. And this is Kurt. I'll just add one, which might get a little bit more into the technical detail. That the WIN Forum, which is an organization that's helping the FCC write the rules, has a definition of what's called sector IDs, where a single radio can have multiple antennas. And that's a capability that both the SASs spectrum controllers we work with and the XRAN system supports to map separate antennas off a single radio. And then XRAN also works as a domain proxy where we can control multiple radios. So we can do multiple antennas on multiple radios, all connecting, and then talking to the spectrum controller. Particularly on indoor, we can coordinate the frequencies so we can get the maximum amount of spectrum that we want and need for the facility. So there's some, but that's why you hire guys like ANS to come in and map and do all that so the enterprise user doesn't have to even think about that.
So I think what you're saying, Kurt, is you can't go to Best Buy and just pick these up off the shelf yet, right?
If you're going to have a dense, high traffic, multi-use system, yeah, that's correct. If you were doing something that is really simple, you had only need 1 or 2 channels, and you're fine with 4G forever, the ecosystem is getting close to that for some installations.
Gotcha. Well, the questioner commented that that was a great answer that you gave before. So, and I think you want to tag team this with Brendan. Follow-up question was, how does the roaming work through GeoVerse with the national carriers in terms of revenue and roaming costs? Brendan, you want to take that, or Kurt?
I can. That seemed to work well last time. I'll start off, and then Kurt can fill in anything I leave out there. From the GeoVerse standpoint, they are a network operator, so they have, and their parent company has, existing roaming relationships with the carriers. So from that perspective, it's more or less a larger version of your bill, where anything roaming goes against a tally of data usage. However, when you're on your own private network, where you control the core and it's on your CBRS private LTE network, that is not charged against any sort of roaming or any sort of quota of data. So that's how that works. But you need to have that existing roaming relationship in place to leverage it. So that's why we went with a partner like GeoVerse.
Kurt, you want to comment on that too?
No, that pretty much covers it. It's I hate to speak for any EPC provider because their business models and packages are always changing, but it can range from they have mechanisms that arbitrates and negotiates that, and they're buying roaming agreements in bulk, so they're getting good rates, and then they package that up either as a per connection or data usage, and that's just a discussion based on the use cases. So it's very likely that a customer might, when they're roaming, maybe not do the video streaming over it, and they just want to do basic connectivity under that model. So there's flexibility there, and that's just understanding the customer requirements. And then there's, again, the beauty of the OnGo ecosystem is there's since it's based on existing technology of the 3GPP, 4G, and 5G technologies, it just happens to ride on a different frequency. There's a lot of selection and choice out there, and interoperability is already proven.
Okay. I'd like to ask one, and you know, the ANS team or Kurt or Ken can answer this. How does CBRS fit into the IoT ecosystem in terms of allowing enterprise clients to be able to get reports and manage their own IoT network? I think akin to what the American Dream folks were talking about before. Do you want to comment on that?
I think I can address it really briefly, but that's probably something that Ken can really get into the weeds more on. They can have a lot of control over reporting because it's their network, and whereas if you have your carrier network, there's only a limited amount you can see and understand about how that traffic is behaving, and you can just get your endpoint information off of it. But with it being your network and your core, as an enterprise, you have the full control and full visibility into what's happening in that. So you understand from A to Z, as far to the weeds as you want to go in terms of network management and analytics. You can see all that. From an IoT standpoint, I'll really let Ken speak to that in terms of the different things you can knit together and information you can pull together on that.
Yeah, thanks, Brandon. From an IoT perspective, if you look at a Cradlepoint router, an endpoint on-premise device, typically what you have attached to that, it's a combination of traditional devices like laptops, PCs, servers, etc. But then you have IoT devices such as an IP camera or IoT sensors such as temperature sensor, humidity, luminosity. And what we've done, there's a variety of ways to connect those sensors into a Cradlepoint router. But we're trying to provide our customers the flexibility to create their own applications to monitor that, because a security vehicle is very different than a digital signage, and digital signage is very different than kind of a retail store environment. So we're partnering with the large IoT platform companies. We've announced a relationship at the beginning of the year with Microsoft with their Azure IoT Central. And from the Cradlepoint router, we can connect sensors to the Cradlepoint router, and then that information goes over OnGo CBRS to the EPC, and then from there it can branch to the Azure cloud. And an enterprise customer can build their own custom application to be able to monitor those sensors or whatever devices they want. And in this particular deployment, the goal is to make it as easy to create that application as it is for a small business to create their own website. You know, you log into a portal, upload your logo, type in some content, and publish. And that's how easy it is to do for IoT applications. So all of my conversations with customers around private LTE also involve the IoT discussion. So it's a great question.
Thanks, Ken. That was great. Final question. Can enterprise clients, enterprise users, realize any roaming revenues from this, from a CBRS network in the ecosystem today?
Unfortunately, Rich, we have to kind of give a non-answer there. We just don't know. We don't know at this point in terms of, there's definitely the potential there, but until those multi-operator carrier networks get solidified, it's undetermined at this point. A lot of it's going to be driven by the venue you have, the user cross-section that you see, and the quantity of those users that's going to derive whether the carriers see it as a benefit and a monetizable benefit to be roaming into your network per se.
Thanks, Brendan. That was interesting, and I think that's, as you said, yet to be determined. So, Paul, any final thoughts from your team or any of the other folks on the call?
Sure. Real quick, Rich, I'd like to thank you and Aaron and your team at 5th Gen and Connected Magazine for hosting this very informative webinar. I'd also like to thank our distinguished panel of Kurt Jacobs from JMA, Brendan Delaney from ANS, and Ken Hosick from Cradlepoint. We really appreciate your time and effort putting this together today, and also for helping us and really being a value partner to us for helping deliver this network and system to the American Dream Team. Hopefully everybody has a great day. If you do have any further questions, by all means, you can reach out to any one of us, and we look forward to doing business with you in the future.
Paul, that was a terrific webinar with a lot of great content, and we really appreciate it. Personally, I learned a lot, and I hope everyone else on the call did too. Thank you. You'll be able to get the slides immediately and the recording of this webinar within a few days. But thank you all for attending.